I know it's low. You've heard of inverses, right? You know that x plus 3, say it equals 7, then the inverse operation would be x minus 7 equals 3. Similarly, 3 times x equals 7, and the inverse of that would be 7 divided by x equals 3, right? Now, say we want to find the inverse of, say, oh no, my pen died again. It's okay, we'll let it charge for a bit. Say we want to find the inverse of 3 to the power of x equals 7. How do we find the inverse of this? This is where logarithms come into play. The inverse of 3 to the power of x equals 7 is log base 3 of 7 equals x. So what the heck does this mean? Well, there's a simple formula that basically explains how to convert exponential functions to logarithms. So say on one side we have undo that. Say we have a to the power of b equals c. Say we have this for our exponential function, right? Now, say we transform, now we have log, and that's going to be base a keep forgetting the color, base a, and base a of c, and that would equal, if this thing lets me, and then that would equal b. This is basically how you transform exponential functions into logarithmic expressions. You can see how it goes from exponential to logarithm. It's basically asking what to the power of a gets us c, and that would be b. This is essentially what it's asking you. So that's how to convert exponents to logarithms. Alright, let's see if my pen wants to cooperate now. So let's say we have 3 squared equals 9. How do we convert this into a logarithmic expression? Well, you need to remember that a is equal to 3, knowing that we have this formula, and we have this formula. How can we convert this? Well, we know that a equals 3, b equals 2 because that's our power, and c equals 9 because that's what we're solving for initially. So now you just basically want to rearrange that in logarithmic form. Oh, come on. In logarithmic form. And that's basically going to be, we see that a is the base in log. So you're going to do log base 3 of 9, because 9 is c, equals 2. It's very simple. That's why this is the base. That's why I call this video basic logarithms, because it's very simple. You're not even doing much math here. You're just identifying what is what, and you're rearranging the equation accordingly. And now say we want to convert from logarithm to exponential form. So let's say we have log base 7 of x equals 2. How do we go from this form to this form? Well, we need to identify that 7 equals a, so we can write that down here. A equals 7, b equals 2, and c equals x. So you can just do this accordingly. 7 squared equals x. And we know that 7 squared equals 49, so we can just say 49 equals x. Both of these are correct. So very simple way of converting it. And you can also evaluate logarithmic expressions too, because we know that logarithmic expressions are just asking for what value to the power of what gets us this value, right? So let's say we have log base 5 of 25, and we want to find out what that equals. Well, it's basically asking 5 to what power gets us 25. Well, we already know that 5 squared gets us 25, so x has to equal 2, right? We can do that in our head. But say we have a question like log 6125. And by the way, when you don't see a base, that means the base is just 10. When you don't see a logarithm expression that already has a base, like a base of 2, a base of 7, or a base of any other number that's not 10 or a negative, then the base is just 10. Just so we're clear on that. So this is basically asking 10 to what power gets us 6,125. And we can't really do that in our head because there isn't exactly a whole number that tells us what power. Thankfully, we have our calculator to evaluate this. We can just put in, you don't even need a graphing calculator for this. You can do this on your scientific calculator. You can put in log, which is right underneath the second button if you have a TI-30XS, log of 6,125, and that would get you 3.78. So there are some logarithmic expressions where you have to use a calculator. Some of them you don't have to use. You will not be using a calculator on the exam or on tests, but some of them you will be using a calculator, like the one I just demonstrated. And also, I want to differentiate logarithmic graphs from exponential graphs. So let's say on this side, we have our exponential graph. Exponentials go like, start very slow and work very high to the top, right? This is our exponential graph. And let's say that on the other side, let's say we have our logarithmic graph. Well, as discussed earlier, logarithms are the inverses of exponential functions. So you can kind of understand what it's going to look like, but if not, it's going to look like this. That's a little messy there, and let me show you why. So when finding the inverse of a function, when you want to find it graphically, you just have to reflect it over y equals x, right? You want to reflect it over this white line. So when you reflect it over this, you'll end up getting this graph. Similarly, when you want to reflect the logarithmic graph over y equals x, like this, you will get this graph. So that's kind of the relationship between the two. They're inverses of each other. It's just as subtraction is the inverse of addition, and just as division is the inverse of multiplication. So those are just the basics of logarithms. Now we need to learn how. Now we're going to learn the properties of logarithms, which is how like the product property, the quotient property, and the power property. Okay, so first off, we have the product property, which is basically saying log base b of xy equals log base b of x plus log base b of y. So let me show you an example of this. Say we have log base 2 of 5x, right? Well, the way that was created is we basically added log base 2 of 5 and log base 2 of x. So when you're adding two logarithmic expressions together, you're basically multiplying this value with this value, you know? So you're basically multiplying x and y together to get the log of the same base of x of y. So that makes sense. Then we have the quotient property, which explains that log base b of x divided by y equals log base b of x minus log base b of y. So kind of similar here, how you can see when we subtract a logarithmic expression from another logarithmic expression, we're dividing the value of x by the value of y. So an example of this would be like log base 3 of y over 4 comes from log base 3 of y minus log base 3 of 4. I keep pressing this button so much. Okay, so that's the product property and the quotient property. That's basically how it works. When you add logarithms, you're multiplying their c values. When you're subtracting logarithmic expressions, you're dividing them. And then there's something else called the power property. And what the power property is saying is log base b of x to the power of n is rewritten as n times log base b of x. So basically that means, like, say we have log base 7 of 3 to the power of x, that can be rewritten as x times log base 7 of 3. That's basically what the power property is discussing there. Okay, now let's do some examples. Say we have, let's start off nice and easy. Say we have log base 4 of x plus log base 4 of y. You can pause the video here if you want to solve it for yourself, but basically this is just going to equal log base 4 of x times y because you're multiplying this value with this value, yeah? Now let's make it a little more confusing a little bit. Say we have log of x minus log of 5 minus log of z. Now what do you do here? Because you're evaluating 3 logs instead of 2. Well, you gotta remember that this log, whoops, I keep forgetting the colors. This log is addition. It's positive because there's no negative sign in front of it. Whereas these two values are both negative because there's negative signs between them. So what you're going to do here, you're going to write your log here, or actually let me do this on the other side so there's a little more room. You're going to put log base whatever here, which is just log 10, so you don't need to put any number really for your base. And then you're going to put in parentheses, you're going to put in the division symbol right there. And for your numerator, you're going to take all the positive values, so x, because log of x is positive. You're going to put that into your numerator. And then for your denominator, you're going to put the values of log that are negative, so 5 and z. And you multiply those two together, so you get 5z. So you end up with log base 10 of x divided by 5z. So that's where it already starts to get a little bit confusing. Now, here's where it might get a little headaching. Hopefully it doesn't, but it might for some of you. Say we have 2 plus log base 6 of x. How can we rewrite this? Well, you gotta remember that when you have like log base 3 of 9, you're basically finding 3 to the what power gets us 9, right? That's kind of the whole point of logs, and that will get us 2, right? So we need to convert this 2 into a logarithmic expression that has the base of 6, so we can properly add these two logs together, right? So we need to figure out log base 6 of what gets us 2. And that's basically just us asking 6 to the power 2 gets us what? And that gets us 36, right? So 2 equals log base 6 of 36. And then you can add these two together, and that would get you log base 6 of 36x. You're gonna have to do that for some problems. You're gonna have to convert normal numbers like 1, 2, 3 into logarithmic expressions. Kind of like what I just did there. Okay. Now, I want you to go ahead and pause this video and try to just expand this logarithmic expression. Okay, so you can go ahead and pause this video and see if you get it right. But if not, then you gotta remember that to expand this, firstly, you're gonna have log base 3 of x squared minus log base 3 of y, because we're dividing by y. We're dividing x squared by y, so we can infer that x squared is in a positive log, whereas y is in a negative log, like this. And then if we remember the power rule, we can actually move the exponent in front of the log to get us 2 log base 3 of x, erasing the exponent from the entire situation. And that would be your final answer. And one last thing I want to show you guys is the change of base property and the natural logarithmic function. So the change of base property, say we have log base b of x, or actually log base b of x, and the formula for this would be log base a of x divided by log base a of b. This is what we call the change of base formula, which is pretty much what it sounds like. So let's put this into action. So let's say we have, I don't know, log base 4 of, say, 17, and we want to change the base to evaluate this. We can change it to, so you can actually change the base to any number that is greater than 0 but not equal to 1. So when we say log base a has to be greater than 0 and not equal to 1. Yeah? So we can do log base 10, which is pretty easy to evaluate on our calculator. So you can put log base 10 of 17, divide that by log base 10 of 4. Don't know why my pen is lagging so much. And then you can evaluate that on your calculator. Log 17 divided by log 4, and that will get you 2.044 if you round it to the nearest thousand, and that would be your answer. Even then though, you're still gonna have to use your calculator to figure out that value. But it makes it a bit easier, especially if you're using a scientific calculator. With graphing calculators, you're able to put in the specific base of your logarithmic expression, whereas with with scientific calculators you can't. And now for your natural logarithmic function, which is basically just log base e of x. And log base e can be rewritten as just ln, which is lane. So whenever you see lane, that's basically just asking log base e. So with that being said, let me give you guys one last problem that I would like for you to solve for. So let's say we have 3 lane x minus 4 lane y. Now you can go ahead and pause the video here and try to solve it for yourself. Okay, so in case you haven't solved it, I'm gonna do it for you. So, oh my god, I keep forgetting to switch the colors. Okay, so going back to our power property, we know that we can put 3 to this power and put 4 to this power. That already simplifies it to ln x cubed minus ln y to the power of 4. Now, we just need to combine these. When you combine these, you end up with ln parentheses x cubed divided by y to the power of 4. And that is your final answer. That's all you have to do.